Hi, and welcome back to Waveform Science. Tonight we're going to go through how to control AC charging on the newest generation of Bluetti devices. So Bluetti has been rolling out some fairly fancy, actually, AC charging options in the Bluetti app that apply to their newer devices. Things like different charging rates, things like amp limiters, things like turbo mode, things like custom UPS mode, time control UPS mode. All of these fairly sophisticated options are available in the app now for units generally AC200L and larger. Units that are smaller than the AC200L have different charging mode profiles as well, and the documentation for how these work is, shall we say, somewhat terse. So we're going to go through that, and more just than going into how it works, it's really why in your use case would you pick one mode versus the other. So very detailed, very technically review. We'll go through it and try to make it as easy to understand as possible. So first off, some scoping. If your Bluetti device charges with a charging brick, like say this one, then this is not the video for you. The charging brick models work in a very inherently different way than the models that charge directly from AC power with a cable going into the device. In other words, if you have this cable, got one of these on this side. For the US models, by the way, EU models will be different, and one of these on the other side. If you've got this one, this video is interesting to you. Even if you have a smaller model than the AC200L, because the smaller units do have controllable charging speeds, and we're going to cover that as well, even though you don't have the more advanced UPS functionality. If your device charges with one of these cables, in other words, an AC200L, we're talking an EP500 Pro, we're talking an AC300, we're talking an AC500. Then this video is going to cover how to use the more advanced modes. If you have the whole house units, those are, generally they don't use a cable at all. They're hardwired to the house. We're talking the EP600, we're talking the EP760, we're talking the EP800, we're talking the EP900. We're going to cover the more advanced UPS modes in that model as well. Our first topic is how to control how fast it charges. We're going to use the little AC2A as the example here for that one. So, controlling charging speed. In the app itself, or on the front of the screen actually, if you press the right button combination, you'll see a method to change it between a standard mode, a turbo mode, and or a silent mode. Now certain devices, AC300 for example, does not have any of those modes. AC500 has a silent mode that you can only get to from the screen of the device, and it's not in the app. And most of the other devices have all three, standard, silent, and turbo. So AC2A, AC70, AC200L, EB3A has all of those modes. Future devices may have those modes and more. So what does those modes mean, really? What's the difference between a silent and a standard? Yeah, each mode has a speed at which it wants to charge. In the graph you're looking at now, you're going to see the AC2A. On silent mode, it wants to charge, and I'm putting this in quotes here, at about 70 watts. If I bump it up to turbo mode, now it wants to charge at over 100 watts. But the line is not flat. Notice none of these lines are perfectly flat graphs where I can set a charging speed, because there's a number of factors that affect how fast it charges. First one, of course, being temperature. As the device gets hotter, it's going to warm up too much, and to protect the battery life, it slows down. So even if you have it set in turbo mode, this is a big misnomer about turbo mode. Even if it's set in turbo mode, it's going to try as hard as it can to charge as fast as it can without overheating the batteries. As soon as it overheats the batteries, it's going to pull back and charge slower. That's actually a big difference between the old charging brick models and the newer wall power cord models, is the charging brick didn't have any way of knowing what the temperature of the batteries were. So because of that, it couldn't really slow down the charging to make it more friendly for the batteries. So for the charging brick, they just had to make it go slow all the time, because otherwise they would risk overheating things. Whereas with these new ones, you can set it to go fast, and it still isn't going to hurt the batteries that much. Now it still is going to warm them up, because turbo mode is go as fast as you can without getting over the thermal threshold. Standard mode is a speed at which Bluetti engineers designed the unit to charge. That is effectively what the Bluetti engineers believe most people will leave it at. Okay, and the speed is different per unit. And again, temperature is going to affect it. The hotter it gets, the slower it's going to go, and there's not much you can do about it. The same thing for too cold. If it gets below freezing, it can't charge. The chemistry is unstable below that temperature. And another common question that I get is, does the device know to not charge below freezing? Yes, if you put it in a freezer and you get it below freezing, or you leave it outside in winter and it's cold outside, and you bring it back outside, it's just going to refuse to charge. It's going to show you temperature on the screen, and it's not going to charge. It will not put itself in danger. So it's got some smarts in it. But how fast is it going to charge? It's this horrible wavy line on the AC2A. It's not one standard speed. There's not a speed it's going to charge at. Okay? And it depends on which device you have and what mode you set it to as to how fast it's going to go. In general, silent is slower, standard is medium, and turbo is fast. In general. But don't expect it to have a standard, it will always charge at X number of watts, because there's a lot more that goes into it. One more tidbit, below 5% or above 95%, it must slow down. It's a limitation of the battery chemistry, and there is nothing Bluetti can do short of switching to a new battery chemistry that will fix that. So if you notice that when it first starts charging, it's charging at like half the speed. Yeah, it's normal. AC200L charging graph. Take a look at this one here. You can see very, very clearly it starts a little slower and then speeds up. It's common. That's how it works. Okay, next, beyond the charging speed settings, there's actually a second mode that on the smaller devices you can't set, but I'm going to demonstrate it. On the larger modes, you can set it. And we're going to talk about this a lot in the next couple of segments, so I need to make sure we cover what this is. And that's the global amp limiter. The global amp limiter is a setting, and here's the AC200L's setting for it, that is, you shall never go faster than this. This is the maximum safe amount of power you can pull from the wall. AC500 has the same setting. Here it is there. EP500 Pro, same setting. AC300 has the same one, but I don't have an AC300 to test, so I can't show you a picture of it. But it's in there as well. But the global amp limiter is what I'm calling it. It exists in the smaller devices too. You just can't set it. And I'll show you what I mean there. So here's an AC2A. I've got it at 60% battery, roughly, and I'm pulling the max 300 watts from the inverter that the inverter supports. I'm now going to give it AC power at the same time that it's discharging. Just flip the switch back here so you guys can see there's nothing secret here. And we're going to start getting input coming in. It's going to slowly ramp up as it charges. Now the input is higher than the charge rate, because I already showed you on the graph of how fast it wants to charge. So why is my input so much higher? Because it's using UPS mode. I've got power coming into this cable and going out of this cable and not going to the battery. It's just going straight from one to the other. But it's also charging the battery at the same time because it does both. So the global amp limiter is how much will it pull from this cable coming from the wall at maximum full blow, and it will never pull more than that amount. And every device has a setting. That's to prevent you from overloading your wall outlet. So this one seems to be set to 565 watts, is as much as it's going to pull with a maximum rated load on it. And I've done other testing, and there's nothing I can do to this thing to get it to pull more than 565 watts from the wall. But you won't find the number 565 written anywhere in any of the manuals for it, unfortunately. And they don't really document what it is. Mostly it's for safety. It's because, let's say I have an AC200L. Let's switch to that model instead. Let's say I have this one plugged into the wall. Let's say I have it plugged into a 15 amp circuit. And because the inverter in here is 2400 watts, I can pull 2400 watts out of the AC200L, but I can't pull 2400 watts out of a 15 amp circuit. It'll blow the circuit breaker. I mean, most house circuits are either 15 amp circuit breakers or 20 amp circuit breakers. And 2400 watts is greater than 15 and greater than 20. So yeah, it's going to blow the breakers either way. So how do you prevent that is very simple, is you program the device so it will never pull more than a certain amount of power from the wall, which then implies that there are multiple modes where sometimes it's pulling power from the wall and sending it straight to the outlet. Sometimes it's pulling power from the wall and then using that to charge the battery. And sometimes it's using power from the wall, charging the battery, and running the inverter from the battery at the same time, and it has to be smart enough to switch between these three modes. We're going to cover 4 different charging modes in the video today, and these are the 4 modes that are available in most Bluetti devices, although in different devices they have different names. First off, there is standard UPS or backup mode, same thing. Next, we have a PV priority or self-consumption mode, again, same thing. Time control UPS or time of use, same thing. And customized mode or custom mode, they're the same modes, they're just labeled differently on some of the different devices. So we're going to cover all 4 of these modes. Much of the videography we're going to be looking at today is used by simply speeding it up. And to make things simpler, I have a clock in the bottom that's going to show how much real time is elapsing. So the clock that says hours, minutes, seconds, those are actual seconds, and we're just watching things sped up. I want to call this out just because we're going to be doing a lot of watching it charging and discharging, and it's going to be doing so rather quickly because we don't want to watch it real time. That would just be incredibly dull. So we've sped things up. The first mode we're going to look at is standard mode charging. In this case, it's set with the amp limiter set to 10 amps. It's going to try charging at 10 amps or 10 times 120 volts, which is 1200 watts. I've got the AC inverter turned on and 120-ish watt load on it. And it started at 0, and it's going to charge all the way up to 100%. I will call out, while this mode is active, the UPS function is turned on, meaning my load devices are actually running directly off the grid. It's passing power in from the grid and out to the AC outlets while simultaneously charging the battery. So this does mean, because UPS mode is turned on, that even if I had solar panels plugged in, my load devices are running from UPS mode. So the solar panels are only going to be being used to charge the battery. They're not going to provide extra power to my devices. So if you want to save money on your power bill, this is not the goal of this mode. This mode is for backup. So why would I want this mode? 2 reasons. 1, backup. I already talked about it. If the power goes out, it switches onto the battery, acts as a giant UPS, and runs your loads. Great, wonderful, that's awesome. 2, if you're solar only, this is a good mode to leave it in, because if you're only running solar, you don't care what the UPS mode's set to. The UPS mode controls AC charging, so let's not have a bunch of extra complicated options turned on if you're not going to use them anyway. So that's a second reason to use this. And the third reason to use this is buffering. And what I mean by buffering, let's say you have X amount of power available, and you need to use an amount of power that is greater than the amount of power you have. I have a couple of examples of these. 1, you have an RV, and in your RV, you have just a 110 volt, 20 amp socket on the side of the RV. You don't have a 30 amp charger. So it's a small RV. And you want to run both a hairdryer and a microwave at the same time. Well, that's more than 20 amps of power. You're going to blow the circuit breaker on, by the way, on the outside of your RV, that you have to go outside to go find the circuit breaker to turn it back on. That's a pain. If you use one of these devices, you can limit the amp, you can set the amp limiter smaller so that it will never blow the circuit, because you're just not pulling too much power as far as the circuit is concerned. And when your load gets higher than the amp limiter, it's going to switch over to the inverter and run your loads. I've done this myself when I'm doing some cooking, and we have an area where we do some cooking for groups, and there's only one circuit on the building. It's sort of a building in the middle of a park, and it's only got one circuit run to it. Well, we've got 3 microwaves. If we turn them all on at the same time, we're going to blow the fuse. So what do? We run a solar generator that has a big enough inverter that it can run all 3 microwaves. Just like lug out the AC 500. And it can run 3 microwaves at the same time. And I set the amp limiter on that to be less than 20 amps, 12 amps generally. My average load is low enough that we don't drain the battery to 0, but we also don't blow the circuit breaker. So that's another use case for the backup UPS mode. One more bit to call out, as it's just about to reach 100% charge on the screen here, is that there are a few components inside the solar generator that have to run off the battery all the time. Specifically, those are the inverter itself and the circuit that determines whether or not the power has gone out and switches to the inverter. If those two circuits are running off the grid, at the point when the power goes out, those circuits will then lose power and it will never be able to switch to the inverter. The inverter takes about half a second or so to spin up, which is too long for it to actually turn on at the moment the power goes out, which means your inverter has to be running all the time. So when the device is full, you'll actually see the battery percentage go from 100% down to 99%, then charge back up to 100%. And it'll do that once an hour or so. And why is it doing that? Because there are certain components that are in fact running off the battery, and they don't want to recharge the battery watt for watt as power comes out. They actually want to let the battery reduce in voltage a little bit and then put some more power back in, and then run it off the battery again for a while and then put some more power back in. So you'll see that happen. Perfectly normal. It does that. I see that question pretty often. So can the battery actually go down when you're in standard mode UPS? As I said before, and kind of gave you a clue to in the microwave example earlier, it can. But it only can when your load device power is higher than the amp limiter. The example I have shown here, I have the AC200L set to 4 amps of charging, or 480 watts, as if I was running it off a 500 watt propane generator. Pretty common size for a propane generator. I put 1,000 watts of load on it. So I'm going to run a water kettle or a boiler or something like that that pulls 1,000 watts. And my generator doesn't put out that much power. Well, if I plug that straight into the generator would go dead in overload mode. So what I do instead is I plug it into the AC200L. AC200L is set to charge 480 watts. Kettle plugs into the AC200L, turn it on, works fine. Why does it work fine? Well, because the moment I start pulling more than 480 watts, it treats it as if the power has gone out, except it keeps charging. In other words, it switches the load to the inverter. My load is running off the inverter, and at the same time, the battery charger is still running. So it's charging the battery as fast as it can while the inverter is powering the load. Now, this is a losing battle, because at some point, if I keep pulling this load, I'm pulling load out of the battery faster than it's recharging. So the battery is going to run to zero if the load continues forever. Normally, these types of high intermittent loads, like a microwave, a hairdryer, those kinds of things, you're not running them 24 hours a day. So there's no real problem with the load being higher than your input limit for short periods of time. But for long periods of time, you'll eventually have the battery hit zero. So what happens when the battery does hit zero? And I left it run to see what happens. The AC output power shuts off, and because at that point it has no more power. There's no place for the power to come from, and it's going to refuse to overload the outlet, because that would be a bad choice. So it shuts off the AC output. It's the safest thing for it to do. And then, because there's still power plugged into it, it immediately starts recharging the battery. Which means if you have an AC200L and you're running off a limited power environment, let's say back garage where you've got a couple of refrigerators in there and you've only got one outlet run to it, using it as a buffer. If you're in that type of situation and you find your AC200L where the AC output has been disabled, but it's full, what probably happened is the battery went to zero and then it recharged. And it went to zero because your loads are too high. So definitely consider, if you're going to be using this as a buffer, the average case of your loads versus the average charging rate, just to make sure you don't wind up with zero battery situations. Now, to turn all this into a nice handy infographic, how does standard mode work? If the AC inverter is off, it's going to charge at the rate specified by the amp limiter and your charging mode until the battery hits 100%, and then it's just going to sit there. If the inverter is on and your load is less than the amp limit, it is going to pass through UPS power to your load while charging the battery to 100% using the maximum available power as set in your charging mode and amp limiter. And when the battery reaches 100%, it will continue to power your loads from UPS mode. If the AC inverter is on and the load is more than the amp limiter, it's going to switch and run the load from the inverter while the input power still continues to charge the battery up to 100%. And then if you hit 0%, the AC cuts off. And if you hit 100%, as I said before, in other words, you're charging up, it will continue powering the load off of the AC power. Next, we're going to take a look at the PV priority or self-consumption modes. So in the AC300, AC500, EP500 Pro, Those devices and AC200L, it's called PV priority mode, and if you go into the app, you can set it, and there's a mode a slider down at the bottom of the app that lets you control a setting called SOC, or state of charge. If you look at EP600, EP760, EP800, EP900, by the way, you have to go into the little advanced menu to bring up the mode that's got the controller in it. There is a self-consumption mode, but it doesn't have a slider. So these are actually the same modes, and just Bluetti chose not to expose the slider. I've reported that to them as potentially a bug, something for them to consider, that maybe they do want to expose the slider. But, and I figured out what it's set to. We'll get to that in a bit. But these are in fact the same modes. My experimental setup here is I have the AC200L. It is set again to 10 amps of charging, or 1200 watts. I have my 120 watt AC load applied to it. The AC inverter is turned on. I started it at 0% and I'm going to let it charge up. By the way, I have my SOC set to 70%. How the process works is it's going to charge from the grid with UPS mode turned on. So again, my loads are being powered directly from the grid, just like backup mode, until it hits whatever my SOC number is, plus 1. So it's going to charge up to 71%, even though it's set to 70%. And then it's going to sit there at 71% and eventually pop down back to 70 and start charging again when it hits the 70, charge up to 71, go back down to 70. And that's how it's going to work until there's solar panel power applied. When I do get up to that charging limit, I'm going to apply what I have in my case is fake solar running off a DC power supply, and that's going to give it 1200 watts of solar, the maximum input it can. You will also notice the grid input stays enabled. In other words, it's going to continue pulling power from the grid even while it's charging from solar. So why does it do that? Because they don't want it in real-world solar cases. Solar isn't a DC power supply. It doesn't come and just stay on. It comes and goes. They don't want it to get to 71%, have solar come in, switch to the battery, then find out it's not enough solar a second later when a cloud comes, and switch back to the grid, and then switch back to the battery. And switching back and forth is not good for it. So what they want to do is instead wait a while until there's enough power in the battery and then switch over to the inverter. And at that point, your loads switch and start running off the actual battery. And if your load gets down to what the SOC is, it will then turn the grid power back on and continue powering your loads. So really, PV priority means your solar panels are the primary source of power above the SOC. Below the SOC, grid power is now your backup. So at this point, your device is helping you actually save electrical money off your bill, by using power coming from your panels instead of using power coming from the grid. So if your goal is to save money, that's the mode to use. Now, why is there actually a settable slider? Two reasons for that. One, everybody's solar array is going to be a different size. Everybody's load is going to be a different size. You want to have it so that it's running most of the time, for some definition of most of the time, off the battery where the power came from your solar panels. But at the same time, you want to have that SOC set high enough that the battery doesn't ever go to zero and shut off on you. Usually, if you're operating in PV priority, you're going to be operating in a 24/7 type situation. Otherwise, this mode isn't actually that interesting. So, depending on the sizing of your device, you're going to wind up setting the slider differently. Why would you want to set the slider higher? So here's the reason for it. You actually want the device to hit 100% every now and then, at least once a week. You want it to hit up to 100%. Because if the battery is floating meaning, 10% to 80%, it's in the middle, and it never hits the end of the charging cycle, what winds up happening is the battery meter in the device becomes decalibrated because there's very little voltage difference between 50% and 70% on the battery. They can't just take a voltmeter, stick it on the battery, read out the voltage. There's only a 0.1 volt difference between 20% and 60% on these batteries, and the voltmeter that's in there isn't that accurate because otherwise it would just cost too much to make. So what you want to do is set it so that it does hit 100% on a regular basis. But you also want that SOC set low enough that most of the time your load devices are running off the battery, such that you're actually saving yourself some money on your power bill. Next, let's say your load is a higher amount than your SOC setting. This is the same as the backup mode that we looked at earlier in that, again, I've gone back, I've set it to 4 amps of charging, 480 watts. We're going to put a 1,000 watt load on it, and we're not going to feed it any solar. So we start at 100%, we're going to go down, and it's not even going to try to charge until it gets below the set SOC. At that point, it goes, oh my goodness, the load is higher than the amp limiter, and I cannot run the load off of the grid because I would be overdrawing what my amp limiter is set to. So it's going to continue running the power off the battery just like it does in backup mode. And it's going to try, when it's below the SOC, to recharge the battery from the grid, which, same problem as backup mode. If that continues for too long, eventually your battery will go dead. But it does, kind of does what I would expect. It extends backup mode and gives you the ability to run your devices off of your own solar panels. So if your goal is to save money on power, PV priority mode is a very significant mode you want to consider. And it is the simplest of those modes. And really the only thing you'll need to do is tweak the SOC setting in order to meet your requirements. We should take a moment to discuss a couple of edge cases here. The first off being if I have solar attached and my load is greater than the amp limiter, which in this particular case I have a 1600 watt load applied. My amp limiter sets 1200 watts and I'm charging at 1200 watts from solar. So in this particular case, it's actually, you can see it's at 78%, the SOC is set to 70%, and it's still pulling power and trying to charge the battery from the grid. Why? Because in the case where the power goes over the amp limiter, then what it does is it switches to the inverter, similar to backup mode, and instead of providing UPS power at that same SOC level, it tries as hard as it possibly can to charge the battery. So you can, in certain edge cases, this particular edge case specifically, get it to try charging the battery in that range between SOC plus 1 and SOC plus 10 if your load is higher than the amp limiter. For the larger Bluetti units, the EP800 appears in self-consumption mode to have the SOC that, as I said before, you cannot set to 21%. You'll see here that I have the device below 20%, and I've set it into self-consumption mode. I don't have any solar hooked up at this point. I do have a load running on it, and it's going to charge up from the grid until it hits 22%, or the SOC setting plus 1, exactly the same as the other devices, and then at that point continue passing through power from the grid and refusing to charge from the grid any further. If I want to turn this into a handy little infographic, it is more complex than the standard charging mode. With the inverter off, it's going to charge from a combination of both grid and solar up to the SOC setting plus 1, at which point it will start charging between SOC setting plus 1 and the maximum, 100%, from solar only. If the inverter is on and your AC load is less than the amp limiter, then it's going to charge from grid and solar combination up to SOC plus 1, where it is then going to continue providing UPS power to your devices until it hits SOC plus 10. Now that's assuming it's charging on the way up. Okay, so then at SOC plus 10, it's going to switch to the inverter and provide power to your devices strictly from the inverter and run you purely off of solar until you hit 100%. By the way, that SOC plus 10 thing, that means you probably don't want to set your SOC setting to 90%. Because if you do that, it's going to provide UPS power all the way up to the top of the grid. And realistically, it's defeating PV priority. So my suggestion would be to not ever set that SOC setting higher than 90. If at any point the AC load becomes higher than the amp limiter that's set in the device, and it's less than SOC plus 10, then it has to switch off of the UPS mode setting because the current that would be going to your loads is higher than what it can pull out of the wall. And it's got to switch to the inverter and run you off the battery. But when it's running you off the battery, whether or not it charges from the wall is controlled by exactly the same set of rules we just covered, so there's no need to duplicate those in the chart and make it more complicated. The third of the 4 modes that we're going to be covering today is the time control or time of use mode for the whole house units. And as far as I can tell, the UI in the app is exactly identical between all the smaller units up to the AC500. So there's two values to set under the SOC setting. There's a lower one and a higher one. I'm going to call the lower one SOC Low, and we'll call the higher one SOC High. In the whole home units, there's only one value listed in the app, and through experimentation, I've determined that that's actually the SOC High value. There is an SOC Low value, but it, just like the self-consumption mode, it doesn't let you set it for some reason. Not sure why on that one. They both work exactly the same way as far as setting the scheduler. It's a single day, starting at midnight, going to 11:59 p.m. on the same day. There's no way to set weekends. So if your power company has different rates on the weekday versus weekends, this doesn't know how to do that. And you can't set holidays either. So it's every day the same thing. And when you go to set it, you need the timing to go in there. Whichever one you program in first should start at midnight and move on into the morning, and then go throughout the day in that order. You want it sorted. And don't leave any times out, because if you have some time that's undefined, it can get a little confused, and I do show what it treats it as later in the video. Before we get too deep into it, I do want to call out that there is an error in the user manual for AC300, AC500, EP500 Pro, and perhaps others regarding the SOC Low setting. In fact, it even says on the screen of the AC500 that when it gets below the SOC Low setting, it stops providing power to your devices. No, it doesn't. That's not right. It doesn't do that. That's wrong. They did fix it in the AC200L manual by simply not telling you what the SOC load setting does at all. So that's kind of a fix of just not telling you what it does. It's at least better than being wrong. But do be aware if you look at this video and then you go look at the user manual and you find the user manual, oh, hey, it says something different. Yeah, you're right. And the user manual's wrong. So let's go into what it actually does. So my first experimental setup, I have time control turned on. I have the amp limiter set to 10 amps or 1200 watts as before, and I have 120 watts of AC load applied, and I set everything to off peak. What that means is 0 hours to 23:59, all off peak all the time. The super short version of what this does is it does exactly the same thing as PV priority, where it's using the SOC high setting exactly the same as the PV priority setting. So in other words, it is completely ignoring the SOC low setting. That setting does nothing at all when it's set to off-peak times. So people have been trying to figure out for a while what it does. As far as I can tell, the SOC low setting, when you're off-peak anyway, does nothing. The SOC high setting is what's important, and the SOC high setting makes it work exactly the same as PV priority when you're in off-peak time. Next, we're going to take a look at what happens during peak time. So everything's set the same, except we've switched over the timing so that 0 hours through 24 hours, the whole day, everything is peak time. And I haven't changed over the video yet because something very critical is going to happen at the very beginning of the video. If you watch the charging right now, you're going to see that it's going to charge up to 3% and then stop. Because it doesn't matter what the SOC low and SOC high is set to under peak timing. It's not going to charge the battery at all from AC power during peak time above 3%. So the other values that you set don't matter. It's not going to charge the battery from the wall. Now notice I didn't say UPS mode. I just said charge the battery. But it will refuse to charge the battery in all cases, regardless of what you set, above 3% during peak time because you don't want to use the power from the grid. In just a moment here, I'm going to apply my fake solar power to the input, and it's going to start charging the battery from solar. But you'll also notice from the grid input on the right-hand side of the screen that it's going to continue providing UPS pass-through to the loads, even though it's charging the battery from solar. Why? Because the battery doesn't have enough power in it yet to actually provide any power to your loads, because it's below, by the way, the SOC low value that they got wrong in the manual. This is what it actually does. So it's used in peak times to control the value of the battery to say when it's below the SOC low, actually SOC low plus 10, it's going to send UPS power through in exactly the same way that the PV priority mode does using its only SOC value. So in time control, when you're in off-peak mode, it uses SOC high, and that controls the value of the battery. When you're in peak mode, it will, one, completely refuse to charge from AC at all above 3%, and two, use the SOC low value, and the SOC low value plus 10 exactly the same way as PV priority does, to control when it's doing UPS pass-through. So it's going to try its hardest to run in peak mode off the battery. In other words, during peak time periods, when your power is more expensive, that's when you'd set peak. And it wants to run your loads off the battery during that time period. But it's not going to keep running the loads off the battery below the SOC low. It's then going to switch over to running UPS, in other words, switch the loads to the grid, because at that point the battery's empty and you want to keep some in reserve. Let's skip a bit ahead in the video here so that we can see what happens at the SOC high setting. And what happens is nothing. So similar to how the off-peak time periods ignore the SOC low, the peak time periods ignore the SOC high. So in short, SOC low versus SOC high, one is used for off-peak, one is used for peak. During peak time periods, it is going to refuse to charge the battery from the grid. It will, of course, charge from solar during peak hours. For off-peak time, it will charge the battery from the grid up to the SOC high setting, exactly the same as PV priority mode works. So what happens if you have holes in your time settings? So same as before, 4 amps charging, 60 watts of load, 30% SOC low, 70% SOC high. And my timer is set up as a clock, but it's off by about 1 minute and 3 seconds. So at 1840, we fall off the end of peak. Before 1840, we were running off the battery because we're higher than SOC low and it wants to run off the battery. When we fall off the end of peak, it doesn't start charging, so it's not really off peak yet, but it starts giving us UPS power. So it's kind of in between peak and off peak. And then when we get to peak time, at 1845, it starts charging the battery because we're lower than the SOC high of 70%. So it's going to start charging the battery off the grid up until we get to 70%, which it's not going to be able to because at 1850, we again fall off the definition into some undefined time zone where, again, my clock is off a little bit. It, again, provides UPS power, but doesn't charge the battery. And then when we get to 1855, it is again then defined as peak. And remember, my time is off drive a little bit. But as soon as we get there, it's going to cut off the UPS power because, again, now we're above the SOC low. So in this undefined time zone, it doesn't know what to do with the battery, basically. So it doesn't charge it. But it will run your loads off UPS power if it can. So my strong suggestion is, when you are setting up your time control, do not leave times undefined. Either have it defined and use it, or don't use time control at all. One of the two. As I mentioned in the beginning of the time control section, the whole house units only have one SOC setting, so let's figure out which setting it is. First off, I have a EP800 here. It is charging off the grid. As you saw, I set the SOC to 20%. It is below 20%, so we're going to let it charge up and see where it stops charging. Everything is off peak at this time, so that means that it should act just like PV priority mode and charge to whatever I set the SOC to. And you'll see that it does in fact charge to 20% and then stop. So the one SOC setting that you have, the only one that's in the app, that's actually the SOC high setting, is what that one is. To determine the SOC low setting, I set the one SOC setting in the device to 35%, set it to have everything be peak time. In other words, the SOC high is ignored and it just uses SOC low, and then let it sit overnight until it got to the lowest point that the battery would get to figure out where the SOC low is. And in fact, the SOC low is 20%. So the SOC low, there is an SOC low in the whole house units. That's EP 600, 760, 800, 900. You just can't set it under the time control setting menu. You can actually set the settings. You just have to go into custom mode, which we're going to cover in a minute. Turning time control UPS into an infographic, we get some additional complexity. The off-peak time is exactly the same as PV priority. That's why we're covering this in this order. But the on-peak time, it will charge up to 3% from the wall. And then after 3%, it's not going to charge from the wall anymore. Above that, it will only charge from solar, but it will provide UPS grid pass-through power up until 10% above the SOC low. And that's if it was providing pass-through power and when you hit SOC low while it's charging. If it's discharging, in other words, you start at 100% and let's say it's cloudy or rainy and you don't have good solar coming in and you're doing peak hours. At that point, it's not going to start providing UPS pass-through mode until it gets to the SOC low. So notice the important bit there is if it was providing pass-through power and you're charging upwards at SOC low, it will keep providing UPS until you get to SOC low plus 10. But the opposite is not true in that if you're going down in the charging, discharging in this case, and you're using up battery power, it's not going to start providing grid pass-through until you hit SOC low itself. The entire video up to this point has been a setup for the section that we're going to discuss now, the ultimate mode, custom UPS mode. It has all the options from all the other modes all put in at the same time. By the way, you can get to this mode in the EP800, but you have to go under advanced to find it. So it's there, and interestingly, it has all the settings that we're missing in all the other modes that I talked about. The PV priority mode missing the SOC setting, well, it's there in custom mode. You can still set it. Time of use mode, missing the SOC low, it's there in custom mode. So if you use the custom mode option, you can get all of those different sliders back that we're missing in the other parts of the UI. So they are actually implemented inside the device. You'll notice that most of the settings in customized UPS are very similar, if not exactly the same, as settings that we've seen in time control mode. Except you've got a couple of switches there. Well, first off, you could turn off the schedule entirely. What does that do? It sets everything to off-peak. So if you turn it off, it's just all off-peak all the time, which also, interestingly, notice that the SOC low, if you remember, was only being used in peak time, which means that if you turn off the schedule and it's all off-peak all the time, now the SOC low just does nothing, which is basically how PV priority mode works. So if you turn it off, it turns it into basically PV priority mode, which means in the EP800 where you don't have the slider, that's how you set it to work in PV priority mode with a customized SOC. Although there is one new option, and that new option is the charge from grid selector. Experimental setup here is we're setting custom mode charging. The amp limiter is set to 10 amps or 1200 watts as we've used before. 1200 watts of load, same as before. SOC low and SOC higher, 30% and 70%. We do have time control enabled. Everything is off peak and the charge from grid switch is off. Was that simple? As before, it's going to charge the battery up to 3% and then sit there and wait for solar to be applied. And then I apply solar, and you will notice that it is charging the battery from solar. There's solar power coming in, but there's not any additional grid power coming in. In other words, I still have 135-ish watts coming in from grid and then passing out to my load. So it is using UPS mode because it's passing 135-ish watts through the system, but it's not charging the battery from the grid. And we are in off-peak mode here. With the charge from grid switch on, what it would be doing here is charging the battery from the grid up until I get to what my SOC high setting +1 is. So when I turn the charge from grid switch off, now SOC high is ignored. It doesn't do anything. And in off-peak times, it's going to pass power through from the grid and only charge the battery off solar. And then in peak time, it's going to use the battery from 100% down to whatever my SOC low is set to. And then below SOC low, it will use grid pass-through. So it makes it operate in a different way. Why would I want to flip that switch? So there's a few jurisdictions in the US, and by the way, I'll call out, I haven't talked to Bluetti about this as to why they did this. But I have a reasonable educated guess. There are some jurisdictions in the U.S. where you are limited in that you cannot charge a backup battery from your utility. It's just, there's laws about that. And this setting allows these devices to be compliant with those laws in the case where you are using it in an environment where you will be audited and someone's going to notice if you have it set wrong. So this allows you to set it in compliance with the law. And it is generally useful to be compliant with regulations because it makes it a lot easier for the power operators to understand how their grid's being used and makes the grid more stable. So if you're in an environment where you can't recharge the battery from the grid because you're just not allowed to in your jurisdiction, you can flip that switch and then it does something sane in that environment. Or the other option you might want to use if you flip that switch is if you really only want the battery to charge from solar and you just want it to be a pass-through the rest of the time. That's another good way of you doing it. In fact, I myself actually have that set on my AC500 to work in exactly that way. So it's not going to charge the battery from the grid at all. It'll only charge the battery off solar and pass through UPS power when the battery gets too low. It's a good way of working. If we turn the ultimate UPS mode, custom mode, into an infographic, this is what we get. The peak time is exactly the same as time control mode. No differences there. The off-peak time is exactly the same as time control mode with the exception that I have added one more line. And that's the line that says, if charge from grid equals off. And that's really the only place it changes, is when charge from grid equals off, it overrides all the other settings from charge from grid equal on, and it just flat up refuses to charge the battery at all above 3% from the grid, and runs you as a UPS pass-through. I hope the last 45 minutes of discussion on the UPS modes was helpful to you, or at least helping you figure out why your units is doing what they're doing. But better than that would be if they help you change the settings so that you have the unit do what you want it to do. The modes are complex, and in going through and figuring out how they all worked, I've kind of divined why it is that Bluetti didn't fully document them in the manual, and that's because they are kind of complicated in how it is that they work. As far as my data sources, I had a few questions that I did ask Bluetti engineers on how various things work, specifically on the EP800 side of things. And those answers were very helpful, but I did independently confirm all of those. Most of the answers of how things work were basically reverse engineered by me taking a device, as you saw during the video, pointing a camera at it, changing all the settings, and going through and charging and discharging. It was about 30-ish cycles on the AC200L, plus and minus, in order to figure out all the information. And yeah, it kind of took a little bit to go through and figure out how it is that these things work. That being said, because this information, the source is from reverse engineering, I cannot guarantee that this will not change in the future. So it is December of 2023, and as of now, every Bluetti device that I've tested, which there's one that I haven't, by the way, I don't have an AC300, so I'm assuming it works the same, I don't have one. But every device I've tested that do have these options, they all seem to work the same way. And it seems that they work the same way on purpose, as opposed to like there's a bug and they work this way. So that's calling out the source of my data. As always, I am not paid to make these videos. I do not receive money from Bluetti. I do not work for them. I do work in tech. I do not work in tech that is anywhere near related to solar generators. I make my money elsewhere. I don't make my money off solar generator reviews. Some, but not all, of the units that are displayed in the video today were provided as purposes for review units. At least one of the units that I showed today, the EP500 Pro, has since been returned to Bluetti. So you don't make money off being a reviewer, not at least if you're not trying to make money, which I'm not. I do this because it's fun to do and I enjoy doing it and other people enjoy watching it. So as long as you guys keep enjoying the videos and I enjoy keeping making them, we'll have more of these. So thank you all for coming and have fun.